I'm Dmitry Chuyko from BellSoft, and we participate in ARM Java work, and we release our own Java, so I'm the part of this work. Our Java is a TCK verified OpenJDK binary, which is called BKK19-203, and basically the company is quite young, but we have strong background in this space. And still, like latest statistics for JDK 12, Oracle dominates in contributions, but still there are other companies like us, like we are in top 5 enterprise contributors. So what's about Java? I think that Java is still good for any kind of application. And it is widely used. It's one of the most popular languages and most popular platforms we have. And it's good for both edge and cloud. It has a wide of, a very long history of what people do with Java. And nowadays, there are interesting changes going on. Like, there's a new release schedule, and all work in OpenJDK space goes according to this schedule. So we now have quite often releases every 6 months. Some of them may be called long-term supported, but still Oracle continues to develop only new releases. And there's a new licensing model where you cannot use Oracle Java in production for free. You have to buy commercial support, and you won't get free security updates. You have to choose some binary provider. But it's still possible. You can get everything for free for long term. You just need to think about that. So what's good about Java also is that everything is specified, and Java virtual machine, there are multiple implementations according to the single same specification. So you can use different virtual machine to the same bytecode. Also, Java language is a separate specification, and you can use any other language that you'll be able to compile to bytecode for your JVM. And a very strong side of Java is security, because you can control what permissions your code actually requires, or that might be not your code, some third-party code, but you still control it. And you can use platform APIs for security and authentication, for transport security, so that's great for cryptography. And of course, we have ecosystem. So Java on ARM, I will be specifically looking at OpenJDK. It's a very cool thing. The history is not as long as x86, but still it's great. We have the important topic here, which is, well, it's easy to find a binary for x86, but it may be a bit more trickier to find a binary for ARM, for both server and embedded. But it's possible. And the second question here is, where do you get security updates? You can use BKK19-203, of course. You can get all the binaries on different platforms, both server and embedded. If you use, well, I assume that you use Linux, because you're going to use Java here. And, well, you can just download the binary, or you can install it using your favorite package manager, one of two. Or you can use a Docker container, even on the embedded device. There are also things like SDK-man and possibly others expected. So what are extras? There are some extras in embedded space. For ARM32, there is a bundled device I/O library that allows you to work with sensors, modems, and all that things. And there's a GUI library called OpenJFX, which is basically an open source version of JavaFX. So you can easily create GUIs, even for not so powerful devices. You don't need X. You can just use frame buffer and it will work. And for the cloud, of course, everything is there, like new and even not so new garbage collectors, JIT compilers, everything we love Java for. So for small devices, it's not true that Java is tremendously huge. You can get nice tiny image for your runtime. It will be like 17 megabytes. That's pretty small. If you include also things like not minimal VM, but client VM, it will be around 20 megabytes. So it's still small. For the cloud, nowadays, we'll use some containers, most probably Docker containers. And there are base images regularly updated for that. So you can use latest Java updates in your cloud very easily to build your own Docker images based on that. Of course, Java is not too unique. It's just a program. So you can run any version of Java in the container. But since Java 8, since Java 8 updates and 9, there are changes that make Java more container aware. I have a separate talk on this, but Java now sees all the limitations that are set, at least most important limitations set in the container. And Java tools work, so they are now namespace aware. So again, you can get a pretty small image even in the cloud that will have old JIT compilers in it. Maybe, I'm not sure about Graal, but probably yes. Or you can use it for development, then you get a huge binary, but still, that's your choice. And of course, for both ARM platforms supported in OpenJDK, we released that binaries and that containers. So I'm going to show a small demo using all that. We'll get some sensor data. It will be temperature in BellSoft's lab that was switched out yesterday. It was funny. Now it should work. We'll use sample gateway. It basically can be like any device that runs Linux and Java. I'll use Raspberry, but anyway. To see how specifications work, they'll use management of that gateway with some external system that will be Bosch Persist. And we'll be streaming that data from gateway to cloud, and then from cloud to some device that is basically a kiosk for the data. For the data from cloud, that may be processed and changed and anything version of the original data. In all that stages, of course, there is OpenJDK, particularly the Liberica JDK. So, what we'll have for the device? Here's a management console. And you see, here's my device deployed with some OSGi implementation, basically modified Apache Felix, or just Apache Felix with some bundles and settings. And here are some specific bundles I have. Like shared runtime for Kotlin language, because with JVM you can use more than one language, as I said. And what's interesting about Kotlin is that, yeah, it allows sometimes newer features for older runtimes, like you can use coroutines and some other language features on like Java 8 JVM. And also you can share code between, for example, your real JVM applications and Android, because Kotlin is now a standard language for Android development. That may be useful. So you can use basically any Kotlin libraries, or almost any. And here's the second bundle, which I created not using any like boss stuff, just using my IDE. That does actual work. So what's inside? It's a very simple application. Here's a bundle activator that just gets the temperature. Here I get, in fact, two temperatures, a temperature of core and a temperature from external sensor. And then I stream that data to Kafka. Main parts of code are also on the slides, so if you need to study it, you can check it later. So what this get temperature does? It is a Kotlin implementation that works with the sensor. It is the actual hardware sensor, and we just read 3 registers there. So we mix Java and Kotlin in the same application, no problem. Sometimes it allows us to write much less boilerplate. Here is not much, but still less, like no semicolons and things like that. And the second temperature source is fairly simple. So what goes next? Oh, so we got the data from the sensor. We have data sheet, we have bundle activator. We need to stream that from Kafka to Kafka. Again, we'll use Kotlin. For this particular purpose, we could use a much simpler code, just to read properties from property file anyway. The Kafka client library is quite fat, like 2.5 megabytes. But you can manage relatively complex things very simple. Like here we just use properties that describe our topic. We'll stream doubles and also timestamps. We won't be harmful for device battery if it uses battery. Like we won't do retries, things like that. So any send will be instant. It will fail or it will succeed. And by the way, here in the activator, we use like 1 second scheduling. It will be also good. All Java internals use OS native threads. So you just, then you sleep, you sleep. There won't be any hidden activity, both for user threads, for application, and for Java runtime. What else is interesting here is that we might configure transport security, encryption, and also client-based authentication on Kafka. So if we would like to secure such small device, it could be done easily. We just need to generate and deploy all the key stores, and that's it, and configure it using the properties. And on broker, we can also manage key store with the keys for devices, for these certificates. So what goes on Kafka? Here is an instance, a cloud instance on Packet. So you probably heard of it. It's Kavim ThunderX. Like, let's check it. Oh. Like you see. There's lots of memory. And I have 2 Docker containers, very simple Kafka setup with Zookeeper and Kafka itself. It's funny, they are running for 2 days, but if you want to use Docker containers, want to isolate that processes, they will fail all the time. Just a funny fact that Docker may be useful in this sense. So we have seen the bundle for our gateway. We've seen the gateway is connected to some management system using just standards, OSGi. Our data goes to Kafka, to 2 topics. Let's check the topics. That's my machine. So I can connect remotely from my laptop to the same Kafka cluster and see what's there. So here are 2 topics called external and internal, which we'll use. And next we're going to process the data on some client. For that we can use JavaFX and still same Kafka clients. So we have Kafka. On that Kafka instance, we might transform the data, like producers and consumers that will bounce the original data between topics, modify them. Anyway, anything that is possible there. We could also do some processing on the device. Like, for example, we could install Flink right on the gateway and pre-process some data there. Like, simple thing, calculate an average or filtering. It may be done right on the device. Also, when we send data, we might not use Kafka client. We might use just MQTT, and then MQTT bridge in the cloud for the Kafka. So for our client application, this kiosk will also wake up every second, get the data and display them on the chart. So here we see some consumer work. I'll just highlight that. It's consumer poll. And our consumer is subscribed to that 2 topics here. And they create our scene. We just subscribe. And then they stop, we unsubscribe, of course. And that's it. That's all the code for UI and for getting data from Kafka, except, again, settings for Kafka, which can be done separately. Here again, we use same description for the topic, and we could use, of course, security and in the same fashion as for the producer. So will it work nicely? I'll start that on my laptop, but as well it shows exactly the same screen, exactly the same result, for example, on Raspberry and other devices. There's absolutely no difference. So like for kiosk, it could be a full screen, right? No X required. In my case, it's probably X, but on the device, it might be not so. No data, right? What's wrong? Here's a question to you. Yeah, we need to start that. So my bundle is stopped. I can just start it using that external system. So what's there? I see, it's pretty cool. So you get all the charts, all the animations of JavaFX on the device, the few lines of code. That's very cool. So what we've seen so far? We've seen device management, gateway code, Kotlin that might be used both for gateway, for the kiosk, on the server. We can use same Java libraries and Kotlin libraries at all stages of our system. We used Kafka easily. Everything was on ARM except my kiosk demo, but it also works on ARM and shows exactly the same screen using JavaFX. That's it. So now conclusions. At gateway, at the client, in the cloud. It all was Liberica JDK 11, latest version. So it's not like embedded applications for Java stopped at times of Java 8. No, it's still possible to get the binary, the latest security updates. And if you get the binary from us, you can redistribute it. You can get it for free. And you can also get commercial support, which will provide like 24/7 support. That's it. All right, so everything works with ARM and Java. And data passes from sensor to cloud and back to kiosk. Thank you. All right, so yeah.
You showed the size of Java and cloud for JDK 8 and JDK 11. So the size was 3 times more.
All right. Yeah, a good question. So here are containers for JDK 8 and JDK 11. It's not the complete table. If you like change 11 to 8, numbers will be close. So it's JRE and JDK.
Okay.
So yeah, that's full JDK. And for and for Java 11, there's no more JRE. But there's an option to get slimmer runtime and slimmer container. Then you just build container. So you get the base image and then build. And it might be, well, small. And with JDK 8, you don't have modules. So modules, we have modules since JDK 9, and of course we have them in JDK 11, and that allows us to produce such a small runtime. Even smaller than JDK 6. Okay, any more questions?
So the Kafka and Zookeeper were running on Packet?
Yeah.
Okay.
Thank you.